Assalamualaikum, my name is Muhammad Amrul Hakim bin Syaiful Amin and my matrix number is 25111042. 25111042. And I will example 6.2. Water flows through a reducing elbow at a mass flow rate of 14 kg per second. The elbow turns the flow upward by 13 degrees and discharge to the atmosphere. We are required to calculate the inlet gas pressure and the anchoring force acting on the elbow. We assume that steady flow, negative friction, and maximum weight of the elbow and water. Since the outlet charges to the atmosphere, the gas pressure at the outlet is zero. The momentum correction factor beta is taken as 1.03. Then we go to continuity equation. Because the flow is steady, the mass flow rate at the inlet and outlet is the same. So we go the equation mass dot equals to rho times area times velocity. And we arrange that velocity 1 for the inlet equals to 14/1000 times 0.0113, and we will get the answer is 1.24 millimeter second. And velocity outlet 14/1000 times 7 times 10 kuasa -4, and we will get the answer is 20 millimeter second. The outlet velocity is higher because the outlet area is smaller. The outlet area is smaller than the inlet area. Then we go to the Bernoulli equation is P1 over rho g plus V1 square over 2g equals to P2 over rho g plus V2 square over 2g plus Z2 minus Z1. Then we rearrange the equation and we substitute the value. P1 gauge equals to 1000 times 9.81. Then we go to velocity outlet 20 square minus velocity inlet 1.24 square over 2 times 9.81 plus 0.3. And we will get the answer from the calculation is P1 gauge equals to 202.2 kilopascal from the x direction. And this is the equation. Then assume that this 1.03 times 14 times 20 cos 30 minus 1.24 minus P1 gauge area 1 to 200.2 kilopascal times 0.0113 is from the area, and we will get the answer is negative 2053 Newton. The negative sign indicates the force acts in the negative x direction. And we will go to the z direction is 1.03 times 14 times V2 is 20 sin 30, and we will get the answer for resultant force at z direction is 144 Newton. Therefore, the elbow must be anchored with a force of 2053 newtons in the negative x direction and 144 newtons upward. And we will go to the last question is example 6.4. That's a water jet with a velocity of 20 ml per second strikes a stationary vertical plate at a mass flow rate of 10 kg per second. We are required to find the force needed to hold the plate stationary. After striking the plate, the water spreads sideways. Therefore, the x component of the outlet velocity is 0. Then we go to the momentum equation. Force equals to mass dot velocity out minus mass dot velocity in. And we arrange that we get negative Fr equal to 0 minus mass dot velocity 1. Then we assume that reactant force equals to mass dot velocity, and we do the calculation. The force calculation is times mass is we get 10, and velocity is 20. So 10 times 20, we will get 200 Newton. Therefore, a horizontal force of 200 newtons acting opposite to the jet direction is required to hold the plate in place. And that's all from me. Thank you.